Hello, that's the question 2 of homework 10. And the question is collect the definition of properties of stochastic processes. So the first one is wide sense stationary process. So what is wide sense stationary process? If we have a process and we get the property of this, which means E, the process is xt equals eta, which is a constant. And the outer correlation of this, which is E x t plus tau x t equals r tau, which is the autocorrelation only depends on the tau, which is the distance between the two times. So this is the definition of white science stationary process. And there are some properties of white science stationary. So uh, which means one uh, when we get when we get a strict science process, which is SSS, and if the process, the second order moment exists, there exists this. So then we can get this is a wide sense stationary process. And if the process xt is normal and it is a wide sense stationary process, we can get it is a strict sense stationary process. So this is the wide sense stationary process. And second, the independent increment process. So which is independent increment process? It means that the increment is independent of time. So if we have non-overlapping two time intervals, which is t1, t2, like this, t1, t2, t3, t4, there are two non-overlapping intervals. And the increment, first increment is xt4 minus xt3, and the second is xt2 minus xt1. So if it is an independent increment process, these two things are independent of each other. So the time, if they are non-overlapping, the time will not influence the increment. So we know that because of this property, we know that like some Poisson process and random walk and because random walk, and we also get the linear process. They are all independent increment processes. So the time will not influence the increment. Third one, which is Markov process. What is Markov process? Markov process means that the past have no influence on the future, which means we have like this p like xn equals xn, and they're on the condition of xn minus 1 equals xn minus 1 and xn minus 2 and so on, x1 equals x1. It is equal to the probability of xn equals xn on the condition of xn minus 1 equals xn minus 1. So only the last part influence the future. So, uh, what is Markov process? So, we know that Poisson process is a Markov process, and because Poisson process and Poisson impulse is also a Markov process, and similarly, like some random telegraph and semi-random telegraph and random walk and linear process, they are all Markov processes. So because the past doesn't influence the future. And four, normal process. So what is normal process? Normal process means that it's a Gaussian process. If we have the process xt and we get the property of the density function of joint density function like this x1, x2, xn, t1, t2, tn, it is equal to this. It follows the Gaussian distribution. So where the x is the matrix of x1 to xn, and the eta is the average of x, and the the c is equal to autocovariance, which means it is e x minus eta multiply x minus theta transform. So this x is the matrix of xt. So if the process follows this distribution, it is a normal process. The fifth one, section stationary process. Section process stationary process is when we have a process and if the f x1, x2, xn, t1, t2, tn, it is equal to when we shift a small epsilon in time, which is x1, x2, xn, and t1 multiply epsilon, t2 multiply epsilon, and tn multiply plus epsilon. If they are the same, then this is a strict sense stationary process. So the little shift in t in time doesn't influence the uh, function. And six, the white noise. So the white noise, if we have a linear process Wt, and we can get the derivative, which is Vt equals dWt over dt. So the Vt is the white noise. And we can get that the average of Vt is equal 0. And the outer correlation of V R T1 T2 equals alpha delta T1 minus T2. So if it is in this form, which is autocorrelation is like not an operator, is like some q t1 and delta t1 minus t2, and the average of it is 0, then it is a white noise. So we can go to the seventh one, which is mean ergodic process. So the mean ergodic process is that if we have an xt process, and if one t goes to infinity and 1 over 2t x from minus t to t, this is xt dt equals the expectation of xt. If one process has this property, then it is a mean ergodic process. So it is equal in mean square sense. And 8, martingales. What is martingales? Martingales is that the conditional mean equals the condition. We can write it like this in this form. So we have xt on the condition of xs equals xs. It is equals to xs. So if the process conditional conditionally equals to the condition, so it is a martingale. And for process, like we know that like some random walk and Wiener process, so they are a martingale process.